Hello, my name is Malcolm Clark and I'm a volunteer here at the National Museum of Computing in Bletchley. We're here in the Large Systems Gallery, which is the gallery that contains all the machines from the 60s. This is my project, my lockdown project for 2021, and it's the restoration of the teletype from a rusty pile of parts, which you can see here, to a working machine. I was working off-site at the National Museum in the store, helping them sort a few things out, and came across these three rusty relics and thought, is it actually possible to make one out of these three which were deemed really beyond repair? And so this is the story of where I started and what we've been able to achieve so far to date. So here's the teletype that we have in operation in the museum. It's connected to our Elliott 903. It's typical of its use in its time in 1960s and 70s. It's the control console for the machine. So it's used to type in commands, to type in your program, and to also see the results of your program. This particular model is the ASR-33, which means it's got a punch for making paper tapes and a tape reader so that you can edit your tapes offline and get them right before you feed them back into the machine through its system tape reader. This is the kind of tape it produces. It uses ASCII code, which was new in the 60s, and this is one of the first machines to make that transition from 5-hole to 8-hole code, in fact the 8-hole ASCII code we use today. Over time, the teletype was replaced by the VDU, which is more in line with what we see today, but similar function. There's a keyboard for manual input, and the screen now shows you what the our computer is doing. The big advantage, of course, is that you don't have the noise that these things make, you don't waste paper all the time, they're much easier to use and run a lot faster. So this is where I started. This simple mechanism, it drives the ribbon. It's operated by this lever here. When the ribbon comes to the end, it flicks this and the ribbon changes direction. And it's as simple as that. So I thought this would be a good example to try to see how restorable these are. And so I stripped it all down, took every screw, washer, pin, circlip, nut off, and cleaned everything, degreased it, and reassembled it. And the restored one is now shiny, still the same operation, and really a good example to say, well, it's possible, even with the wear that's on here, to get this thing back in a working condition. This is a good test for the restoration process. If I get this piece working, the technology in the device is just more of the same. There's aluminium castings, plastic items, small circlips and shafts, and lots of stamped pieces. And that's really what goes into making a teletype. So now I'd like to take you through a series of photos and videos of my restoration of the machine. It shows them breakdown of all the parts, cleaning and the reassembly of the whole machine. So this is the carriage as we've started to strip apart. You see in the background some of the parts I've taken off. So by splitting it into these sorts of pieces, I could get some sort of control of what I'd taken apart and what I put together. Because so many of the parts, the little springs, the washers, look the same, but are slightly different. So this is the first clean-up. So these has all been soaked in degreaser, washed and dried. This is the main head and lifting mechanism. There's a small cage on the left-hand side which rotates and tilts so that you can print on the 4 different levels of the head and anywhere in its rotation. And here it is back together. I oiled the surface of every part and every bearing, and I had to steal some pieces off one of the others to make this work. One of the challenges of this printer is its age. This particular point that I'm pointing to is the hammerhead pad made of rubber, and they'd all just disintegrated. And it's really important to have a rubber pad, otherwise as you print each character it damages the print head with the metal-to-metal contact. A little bit of internet research, and the traditional fix is just a piece of rubber sleeving, so that's what I put here with a tie wrap around it, and it seems to work well. This is the power unit from the printer I decided to repair. It is mainly electrical, there's very little electronics. Some diodes to make rectified power supplies and 2 or 3 transistors to drive the selector magnet. But basically it's electrical and it drives relays and the motor. This is the one capacitor I couldn't replace. It's strange because there are 2 capacitors in one enclosure and they don't make them anymore. As you can see, there's a date on this capacitor, May 67, gives us some idea of when this machine was first produced. So this is one of the arc suppressors. I had to replace all 5 within the machine, but I only learnt that by experience. First time I powered this power supply up, there was a puff of smoke and a blown fuse. So off to the suppliers to find an alternative. Unfortunately, they didn't have the screw-in type, which were originals, so I've had to replace them with the same electrical performance, but they just have to be tie-wrapped on. I couldn't find a diagram for this power unit anywhere, so I decided I had to draw my own. So in the background you can see the beginnings of the diagram that I was putting together by just manually tracing every wire in the power unit. The card on the top left is the selector magnet driver card, the SMD card. Here you can see on the left somebody's played with the resistor values in the past. This part of the circuitry was to do with receiving data from a line. Traditionally this machine would have used an 80 milliamp current loop system. So by the look of it, somebody's had to adjust the current around the loop using different values of resistors, and 2 in series seem to solve the problem. So here's the completed power supply. I've replaced all the capacitors and it's raring to go. Here's the start of the major strip down, a note of the 5,802 hours that this machine's motor had been running. Of course we don't know how many times it's been around the clock. At this stage, I don't even know whether the clock had stopped. So here's the electrical system, the motor. This is a 115 volt motor, synchronous motor, so it's quite powerful, but prone to going in 2 directions unless you build in a start circuit. So this has a little start relay that pulls in when you first run the motor up to make sure it goes the right way. So you can see the space left without the motor, but it reveals some of the mechanics. This is a picture of the main shaft. This has to rotate twice to print a character, which is something I discovered in taking it apart and understanding how it worked. That one character is stored mechanically within the machine, ready for printing, and it can then go ahead and start receiving a second one and storing it in the selector. So this is the area on the left at the front, and it's all to do with carriage return. There's lots of levers in there, but you can see here some of the rubbish that's fallen inside. There seems some sort of fur as well as dust and general rubbish. This is one of the pieces buried deep within the machine. This is a rocking shaft that drives the mechanism forward, provides power into all the different parts of the machine. So there we are, finally everything's removed, base casting started to clean up, so soon to start putting back together. The sub-assemblies that are still to be cleaned up and sorted out. Now the little yellow bottle is the oil. Teletype made their own oil and grease in the original day, which of course is not available. So some internet research led me to this particular kind of oil which was available in the UK, which had the right viscosity and would hopefully keep this machine going for many years ahead. So here we are. This is the start point of reassembly. The casting is cleaned, all the bolts removed, and we're ready to go. So this is the first part to put back into the casting, as shown here with, and it's still its dirty state, but these long rods run all the way from the front to the rear to connect to the keyboard. And it takes the mechanical tripping from the keyboard and trips that cog in the background, in the top, to drive the transmission process. Assembling those rods that connect the keyboard to the printer was tricky. They were buried right in the bottom, and perhaps I hadn't taken enough notice of when I took them out because I couldn't get them back. So I had to go back to the other machines and have a look round, take a few pictures to try and work out exactly how to put them together. So all these are really 3 trip levers, 3 ways of telling the machine to send a character. One from the keyboard, one from the tape reader mechanism, and another automatic one which was used to trip the answer back mechanism. This is the function area in the base, so this is the next layer to be built up inside the casting. These are function levers, and they're used to do the non-printing functions. Each one of these levers does a different job, so either printing a space, or ringing the bell, doing a carriage return, or line feed, running the line feed mechanism. There's a system of customization in the Teletype where you choose which levers you put in for which functions you want. These are the basic ones. So here's an example from the manual. The manuals are freely available online, but they describe the generic printer with all its options. A lot of the springs are very similar, but do different jobs. So they can be different lengths, different diameters, but also made out of different diameter steel, so they have a different strength. I'd be really careful to put the right spring back in the right place. So now we can see things starting to come back together. The rocking shaft in place, and all the function levers are all there. So this part is the next layer. It's where the data moves through the machine. This is called the code bar basket, and it transmits mechanically from the selector area on the right through the bars that run along and passes the data pattern that needs to be processed into the other mechanics. Here you can see the code bars taken out and the different projections on the bottom of them, particularly on the left-hand side. And these are what those function levers drop into, depending on the code that's selected on the bars. So these lugs line up or leave a space. If there's a space, then the function lever will drop in. So depending on the code on the bar, depends which function gets activated at the next stage. The machine works on an 8-bit code, but here there are 9 code bars. The one at the bottom is called the print suppression code bar, and that's used to stop it printing physically if it's a non-print character like a carriage return or line feed. So here is it all cleaned up in place. So this is the main drive shaft. On the left you can see the selector cams where the data is transferred from electrical signals into mechanical signals. Here those levers are in place and the springs attached at the top. So here's the reader trip. This solenoid is activated from the electronics and mechanically trips a little clutch which takes the drive into what is called the distributor to send the data off to the line. So here is the selector. This is the heart of receiving data from the line. It takes electrical signals and converts them into the 8-bit mechanics to drive through the machine. That big screw is the timing knob, and it adjusts when the mechanical operation starts relative to when the first electrical signal arrives. And one of the tests is to see how sensitive this is, how far you can move it before it starts to fail, both forwards and backwards. So this is the selector. On the top right is the selector magnet itself. So the data, serial data, is fed to this magnet, and it either attracts or releases the armature as each piece of data, each bit of data comes through. That is then allows the levers on the left, the long black ones, to either move up or get blocked. And that's done for one rotation of the shaft. Once the data has been lodged onto those levers, they all get pushed down. That pushes the levers on the right-hand side, the vertical levers, downwards, and lifts the last set of levers with all the little lugs up according to what data patterns just arrived. So there's a 3-stage process to receive it, and that's done in one rotation. But once it's received that character, it can start to receive the next and reset the levers with the cam. And here we are, almost in one piece, with the carriage repositioned and just waiting for the motor. The printer I'm restoring didn't have a working keyboard, it was a pile of bits. So this is the keyboard from one of the other printers. In front of you, you can see a broken part. This is the trip lever from the keyboard, and it's the only one I have. So here you can see the basic parts of the keyboard. There's a pile of keys, a set of code bars, and some electrical contacts on the top left. So the keyboard works by having a pair of levers under each key, which have got mirror image slots in them. So as you press a key, each of the bars will either raise or lower the odd or even bar. When one is pressed, you can't press another one because it's blocked by all the other bars. Luckily, all the code bars are numbered so that they were fairly easy to get back in the right place, although there are lots of parts in the keyboard, far more than I expected. Here you can see the encoding on each of the code bars. Down the bottom left is the broken part, and next to it there's a strange H-shaped piece of metal, actually called the H-plate, and it's the link between the keyboard and the main part of the printer. So each of those code bars interacts with this set of contacts to make 8 separate circuits, one for each bit in the character that you've selected. So as you press the key, these contacts move in and out and pass the signal on to the distributor. So here is the printer turned on for the very first time. The motor's running smoothly, it's not binding on the shaft, and a characteristic noise that they make. I've just partially assembled the keyboard just to get the minimum configuration. So the first key press triggers the system. The machine's in local at the moment, so when you press a key, you can just see the H plate give a twitch as it triggers the clutch at the back, and this is the distributor going around converting the parallel data from the keyboard to a serial stream of data. That's sent back to here in the selector, where it's converted back to a parallel motion to put out on the code bars. So here in the bottom of the code bars, every time a key is pressed, they move to replicate the code that's been sent from the keyboard. That travels along and into the carriage and makes the head move to the right position to print the character. These are non-printing characters, but sent continuously, And you can see the distributor running at full speed now, and the whole mechanism's in action, and pretty stable too. It's not over tripping or doing anything unusual or getting stuck. You can see the data right in the centre of the screen. There's a little black flicker. That's the solenoid in the selector bringing the data through. And the head going at full speed, which is 10 characters a second. Next thing is to do some final cleaning. So this is the base. It's application of some new primer just to keep the rust at bay. So here's the underside of the platen, with the roller that takes the paper, and the dash pot. The carriage return mechanism is quite crude. You release the carriage and allow it to return on a really strong spring, and then plunge a piston into this cylinder, and the air blows out through a little hole in the back. And just by adjusting the size of the air hole, you can adjust how much cushioning goes on at the end of a line. Although it's fairly simple, it's one of the key adjustments to get a clean printout at the beginning of every line. And here's the final assembly with all the contacts back in and the contact strips. Not really been able to remove all the rust, but a coating of oil hopefully will stop the rust getting any worse. Here we are, the first printing on the printer with the platen in place and some paper to print on, and one of the old ribbons in place. It's a message from the future, really, because when this printer was first used, the term "Hello World" had not been coined. So one of the last areas is the punch. This is a kind of standalone piece which can be added on. It's one of the things that makes this an ASR-33, an automatic send-receive, the tape facilities. So here we are, all stripped down. Like the selector, there are sets of levers which move the data through to different sections of the punch. Each layer has its own function and produces a separate drive for each of the pins in the punch block to make the holes in the paper tape. Here's the punch back in use. The pattern you can see is alternate noughts and ones, which are the codes for a U and an asterisk. So that's a common test pattern for the Teletype, just so that you can see that bits alternate correctly. Here there's a slight modification with a polythene bag on the right-hand side. This is to collect the chads from the punching. Teletype has chads all over it. I've scraped and picked off chads that have got glued on each of the pieces, especially in this area. They just spread throughout the printer in its life because they spill out just from time to time, because they're really just designed to go down a little tube and through the hole in the base and hopefully get caught by a little plastic bucket. So here's the only tape reader. It looks really dirty. The tape reader back in one piece, cleaned. It looks quite different now. So, this is it, a fully working machine. I've pre-typed a tape and fed it back into the tape reader. So the characters are being read by poking little pins through the holes. So it's going around the system and being re-punched here. So you can see what a test pattern is. It's the U stars that we've seen before, but also a very familiar phrase, the quick brown fox jumps over the lazy dog, which is called a pangram, and it contains all the letters of the alphabet, and it was the thing that I remembered from my time working on teletypes. An exercise there testing the dash pot and how cleanly it returns after doing lines. And now I'm going to have a look at the course of data through the machine. The data's coming from the tape reader onto the distributor, where it's picking it up, and that is then sending the data through to the selector at the other end, where it's converted into parallel mechanical data to drive the rest of the mechanism. And this should go on all day, just replicating itself. So once it's all back together, that wasn't the end of the story. Getting it to work and operate was a good start, but there are hundreds of adjustments. In fact, there are 100 pages of adjustments in the manual, and some of those I needed to do to get it working, but others were related to print quality, and they were some of the trickiest ones to sort out. So with something of this age, it's worn, it's quite well lubricated now, but it still needed some little tweaks and some quite tricky tweaks to get it to print to the quality I wanted. You can see here the difference in the strength of characters across the top and bottom and left and right. And also down here, the left-hand margin doesn't give the same spacing as the rest of the line. So both these adjustments are in different parts of the machine, and it took me a week to do each of them. It became so frustrating I had to just leave it for a while and then come back and do a very small tweak. And eventually I managed to resolve it. And this is what we have today. And that is just about the best I can get it. Well, I hope you've enjoyed this video of the restoration of a Teletype ASR-33 here at the National Museum of Computing. We are a working museum, so you're really welcome to come along and see our exhibits of working machines from back to the oldest machine working in the world is the Witch, and through here into the Large Systems Gallery, where we have a working example of Teletype, which you can come and type and have a go for yourself. And I'll leave you with just the machine running in its working state.